Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 11 from the October-November 2019 International A-Level. This is Cambridge 9709. This is paper 1, variant 3. And this question here is also question number 6 from my end of topic worksheet on integration from my P1 collection of topic-wise questions. Now, the question number 11, part A here is about this, basically this curve and this line here, which it says, the diagram shows part of the curve y equals x minus 1 to the power of negative 2 plus 2, and the lines x equals 1 and x equals 3. The point A on the curve has coordinates 2, 3. The normal to the curve at A crosses the line x equals 1 at B. Show that the normal AB has equation y equals a half x plus 2. So we've got to find the equation of the normal to this curve. Now, what does it mean by normal to a curve? Well, the normal to a curve is basically a line which has a gradient which is perpendicular to the tangent to the curve. Okay, so for example, if I draw a line here at a tangent to the point to the curve at A, let's say that's a tangent to the curve at the point A. Just touches the curve at point A without cutting through it. So it has the same gradient of the curve at point A. This is the tangent and this is the normal. The normal has a gradient which is perpendicular to the normal, is perpendicular to the tangent basically. Okay, so what we need to do is we need to find the equation of this straight line, AB. Okay, as we said, it's a normal, so therefore its gradient is perpendicular to the gradient of the tangent. Now, in order to find the equation of a straight line, we need two things. One thing we need is its gradient. Okay, so we need to have the gradient of the normal, called Mn. And the second thing we need is a point on the line, which actually we have. We know that 2, 3 is on the tangent, the tangent and the normal. The normal passes through the point A. Okay, so if we find the gradient of the normal, we can then easily find the equation of this line and show that it gives you this equation. Okay, so the first thing we need to do now is to find the gradient of the normal. So we need to find dy dx. The first step, we need to find what the gradient function is for this curve and find the value of the gradient at the point A when x equals 2. So to differentiate this, we need to use the chain rule where we have x minus 1 to the power of minus 2. So what we're going to do is we're going to multiply by the power. So you have minus 2 times x minus 1 to the power of minus 1. Take 1 from the power. So you multiply by the power, take 1 from the power, and then you multiply by the differential of what's inside the function. Always get used to doing this, because if there's a number in here, okay, if there's a number next to the x, then you should multiply by the differential of what's inside here. In this case, it happens to be 1. Okay, the other thing you got to check for is, are we able to differentiate in this way? That's fine. That's okay. So now we got this as dy dx equals minus 2 over x minus 1 to the power of 1. Now, when you differentiate the plus 2 here, it becomes 0. So that is the gradient function. So we can say that the gradient of the tangent is going to be, at the point A when x equals 2, is going to be minus 2 over 2 minus 1, which is basically minus 2. So therefore, the gradient of the normal that we need is going to be the negative reciprocal. So when you have a normal and a tangent, the gradient of the two perpendicular lines is always the negative reciprocal of each other. So if the gradient of the tangent is negative 2, the gradient of the normal is going to be the negative reciprocal. So you change its sign and you write it as its reciprocal. So you end up with a half, because minus 2 is the same as minus 2 over 1. So the normal gradient will be a half. As we can see, that looks just about right there. So now we're going to use our formula y minus y1 equals m times x minus x1. Many students don't like to use this. They prefer to use y equals mx plus c. Both are perfectly fine, and I'll show you how to use both of them for those of you who would insist on using it. I prefer to gently push my students to use this, especially for what comes later on. Anyway, no problem. Let's just use this formula first. So you have y minus 3 equals, the gradient is a half times x minus 2. So we replace the y value with 3 and the x value with 2 over here. And now we can simplify. Now they want it in this form here, y equals mx plus c. So what I'm going to do is I'm going to expand this. It becomes a half x minus 1. If you multiply a half by minus 2. And then because they've given us the answer, I'm going to just show the steps a bit more clearly. So on a half x minus 1, I'm going to show that I add 3 to both sides, which gives you y equals a half x plus 2. And that's what we had to show. So that's part 1 done. Oops, part 1 done. Now we could also do this in another way. We can use y equals mx plus c. We know that it goes through the point A, which is 2, 3, and the gradient is a half. So we can say y equals 3, m equals a half, a equals 2, okay, plus c. So you have 3 equals a half times 2, which is 1 plus c. Therefore, c equals 3 minus 1, which is 2. So therefore, we can say y equals a half x plus 2. Either way is fine. You can use this way, that way, you get the same answer, of course. Okay, so there's your answer to part 1 of this question. And I'm going to save this as a separate video to part 2, because this is really to do with the topic of differentiation. So this is going to be in my playlist for differentiation. Okay, and so that's dealing with finding the equations of normals. So that's really under differentiation. So as I said, I'll save it under that playlist. So part 1 of this question is going to be in the playlist for differentiation. Part 2 will be under integration, where we have to deal with volumes of revolution. That's what's going to come in the next video after this. So basically, if you would like to see other questions from this particular paper, which is the variant 3 from the October-November 2019 9709 exam, then you can go to the playlist over here. Okay, if you would like to see questions from the topic of differentiation, okay, from differentiation. In fact, if you want to see other questions from this end of topic worksheet, okay, number 13, you can go to the playlist over here. This playlist is all about integration. This is just part 1 of the question. If you want to see other questions dealing with differentiation from my playlist, you can look over here. This is all differentiation questions dealing with P1 9709. If you want to subscribe to the channel, you can click on this link over there. Thank you for watching, and see you soon.